Welcome to Vidyaskritra YouTube channel, a dedicated place for developers, learners, and professionals to upgrade their knowledge with real-world concepts and practical explanations. Hey developers! Welcome back to the channel. In today's session, we are going to unlock one of the most important principles in clean coding and professional software development, the open-closed principle. If you've ever faced messy code, bugs appearing after every update, confusion while maintaining projects, or fear of touching old code because something might break, then this video is absolutely for you. Today, I'm going to explain the open-closed principle in the simplest way possible with real examples, real coding scenarios, and crystal clear explanations. Now let's understand the official definition of the open-closed principle. The open-closed principle states that software entities like classes, modules, and functions should be open for extension but closed for modification. It means our existing, working code should remain untouched and safe, but we should still be able to add new features or behaviors whenever needed. Instead of changing old code and risking new bugs, we extend the system using concepts like interfaces, inheritance, and design patterns. By following OCP, we make our applications more stable, easier to maintain, and future-ready, even when business requirements keep changing. So now the big question. Why do we need the open-closed principle? Why is it so important in real-world software development? Because in real projects, requirements are never permanent. Clients change their minds, new features are added, business rules evolve, and applications keep growing. If every time a new requirement comes, we start modifying old code, we increase the chances of breaking existing features, introducing new bugs, and making the system unstable. By following the open-closed principle, our code becomes safer and more reliable, because the tested and working logic remains untouched. We simply extend the system by adding new modules or classes instead of modifying old ones. This makes the software easier to maintain, easier to upgrade, and much more scalable. In simple words, OCP helps us build professional, flexible, and future-proof applications that can handle change without fear of breaking things. So now let's talk about where we actually use the open-closed principle in real life. We apply the open-closed principle in any place where our software is expected to grow, change, or receive new features in the future. This includes areas like payment systems, notification systems, logging, reporting, business rules, and almost any feature that may need frequent updates. Instead of modifying old code again and again, we design our system in a way that allows us to simply plug in new functionality. You'll see OCP used in large enterprise applications, banking systems, e-commerce platforms, and cloud-based solutions where stability is extremely important. Whenever we know that this feature may expand later, that's the perfect place to apply the open-closed principle. In short, we use OCP wherever we want flexibility, scalability, and safe growth in our software. Now let's understand how we actually implement the open-closed principle in real development. We follow OCP by designing our system in such a way that new features can be added without modifying existing code. And we achieve this mainly using abstraction and polymorphism. Instead of writing logic directly inside one big class, we create interfaces or abstract classes and define common behavior. Then, whenever a new requirement comes, we create a new class that implements or extends that abstraction. This way, we only add new code, we don't change the existing working code. We can also use popular design patterns like strategy pattern, factory pattern, dependency injection, and plugin architecture to follow OCP more effectively. These patterns allow us to plug in new behavior easily, just like adding a new module to a system. So in simple words, we apply the open-closed principle by designing flexible code using abstraction, writing extensible modules, and adding new features through extension instead of modification. Let's now look at some real-world practical examples where the open-closed principle is actually used in the software we use every day. Example 1: Payment systems. Think about e-commerce websites like Amazon, Flipkart, or any online shopping platform. Initially, they may support only credit card payments. Later, they need to add UPI, net banking, PayPal, wallets, and many more options. Do they rewrite the entire payment code every time? Of course not. They design the payment module using abstraction so new payment types can be added as separate classes without modifying the existing working code. This is the open-closed principle in action. On the left side of this image, we see a clear violation of the open-closed principle. Here, we have a single large payment processor class, often called the God processor, because it tries to handle everything inside one place. Inside this class, we keep writing multiple if and else if conditions like credit card, UPI, net banking, and PayPal payments. Every time a new payment method is required, we open this class again, modify the code, add more conditions, and risk breaking existing working functionality. This approach is risky to change, prone to bugs, hard to test, difficult to maintain, so this clearly breaks the open-closed principle, because we keep modifying the same existing working class again and again. Now look at the right side. This shows OCP done correctly. Here, we design the system using abstraction. We create an iPayment interface that defines a stable contract with a pay amount method. Our payment processor now becomes closed for modification and depends only on this interface. Now whenever we need a new payment type, we simply create a new class such as credit card payment, UPI payment, or PayPal payment, each implementing the iPayment interface. We extend the system by adding new classes instead of modifying old working code. This approach is safe to extend, stable and maintainable, easy to test, future-proof, and that's the core idea of the open-closed principle. Add new functionality by adding new classes, not by constantly changing the existing payment processor. Example 2 Notification systems. Consider applications that send notifications. At first, they may support only email notifications. Later, requirements come to add SMS, then push notifications, then WhatsApp alerts. Again, instead of changing the old notification logic, developers add new notification classes that extend the same interface. Old code remains safe, new features get added smoothly. On the left side of this image, we see a clear violation of the open-closed principle. Here, we have a single large notification service class, often called the God class, because it handles everything. Inside this class, we keep writing multiple if and else if conditions like email, SMS, push, and WhatsApp notifications. Every time a new notification type is required, we open this class again, modify the code, add new conditions, and risk breaking the existing working features. This approach is risky to change, prone to bugs, hard to test, difficult to maintain, so this clearly breaks OCP, because we keep modifying existing working code. Now look at the right side. This is OCP done correctly. Here, we design the system using abstraction. We create an interface called iNotification which defines a stable contract, like a send message method. Our notification service becomes closed for modification and depends only on this interface. Now whenever we need a new notification type, we simply create a new class like email notification, SMS notification, push notification, or WhatsApp notification, each implementing the same interface. We extend the system by adding new classes instead of modifying the old one. This approach is safe to extend, stable and maintainable, easy to test, future-proof, and that's the core idea of the open-closed principle. Add new functionality by adding new classes, not by constantly changing the existing working code. Plugin architecture. Applications like VS Code, browser, and game engines allow plugins. You can install themes, extensions, tools, all without changing the original software. The base system is closed for modification but open for extension through plugins. This is a perfect real-world demonstration of OCP. This image demonstrates one of the best real-world implementations of the open-closed principle, known as plugin architecture. In the center, we have the base system. This is the main application and it is clearly marked as closed for modification, meaning once the core system is built, we don't keep editing or changing it every time new requirements come. Instead, the system provides slots or extension points, like theme slot, extension slot, tool slot. Now look at the left and right sides. Here we have plugins, such as theme plugin, tool plugin, extension plugin. These plugins are open for extension, which means developers can keep building and adding new plugins anytime without touching the original base system. Whenever we want to add a new theme, new feature, or new tool, we don't modify the base application. We simply plug in a new module into the respective slot. The base system stays safe, stable, and unchanged, while new functionality keeps getting added smoothly. This is exactly how applications like VS Code, browser, IDEs, and many enterprise systems work. They follow the open-closed principle by keeping the core system closed, but making the plugin ecosystem open for endless extensions. And that's the key takeaway of this image. New functionality is added via plugins, the original software remains unchanged. This makes the system flexible, scalable, and future-proof. Example 3: Tax calculations and business rules. In banking, finance, or government systems, tax rules and business policies frequently change. If developers modify the same code repeatedly, it becomes a bug factory. So they follow OCP. Existing logic stays untouched and new rules are added as new modules. This keeps the system stable even when laws and policies keep changing. In this example, we are looking at how the open-closed principle works in a real-world tax calculation system. On the left side of the image, we see the wrong approach, a tax calculator designed as a single, God module. Inside this one big class, all tax rules are written using multiple if and else if conditions like old rule 1, old rule 2, and even the latest new tax rule 2024. Every time the government updates tax policy, developers must reopen this same calculator, change its logic, and add more conditions. This is extremely risky, because modifying existing working code can easily introduce new bugs. It also makes the system hard to maintain, hard to test, and highly unstable as it grows. This completely violates the open-closed principle because we keep modifying instead of safely extending the system. Now look at the right side. This is the correct professional way to design it. Instead of writing all rules inside one class, we create a stable interface called iTaxRule with a method like calculate income. The tax calculator now depends only on this interface and becomes closed for modification. Whenever a new tax rule comes, we do not change the tax calculator. Instead, we simply create a new class like GST. In applications, logging may initially be done to a file. Later, you may need to log to a database, cloud, or monitoring tool. Instead of rewriting the logging system, we just add new logger classes. Again, no modification, only extension. So in simple words, whenever a system is designed to grow safely without rewriting old code, the open-closed principle is working behind the scenes. This image clearly demonstrates how the open-closed principle can be applied in a logging system. In the center, we have the main logging system, which is marked as base code, closed for modification. That means once the logging framework is developed, we don't keep changing its internal code every time we need a new logging feature. Instead, the system relies on a logger interface that defines a simple, stable contract with a method like log message. This interface never changes and acts as the foundation of the entire logging mechanism. Now look at the loggers around it. We can have a file logger, a database logger, and a cloud logger, and each one simply extends the logger interface and implements its own logging mechanism. If tomorrow the project requires a new type of logger, like an email logger or monitoring logger, we don't modify the original logging system. We simply create a new class that implements the same interface. This way, we are adding new functionality through extension, not modification, which perfectly follows the open-closed principle. This design keeps the core system stable, reduces bugs, makes the code cleaner, and makes testing much easier because each logger can be tested independently. Most importantly, it makes the system highly scalable and future-ready because new loggers can be plugged in anytime without touching the existing secure and tested code. The key takeaway is simple. New loggers are added via extension while the base logging system remains unchanged. That is the real power of the open-closed principle. Now let's talk about the advantages of the open-closed principle and why it is so powerful in real-world software development. First, it makes our code stable and reliable. When we don't modify existing working code, we don't accidentally introduce new bugs. The tested code remains safe, and the application becomes much more trustworthy. Second, it gives us easy scalability and future growth. As new requirements come, we simply add new classes or modules instead of rewriting old ones. This makes it super easy to enhance the system without fear. Third, it improves maintainability. Code that follows OCP is clean, modular, and well organized. Developers can easily understand it, update it, and extend it even after years, which is extremely important in enterprise projects. Fourth, it supports team collaboration. Different developers can work on new features independently by creating new extensions without touching each other's code. This reduces conflicts and improves productivity. Fifth, it encourages good design practices. By using abstraction, interfaces, and design patterns, OCP helps developers think in a professional and architectural way rather than just writing quick fixes. In simple words, the open-closed principle helps us build robust, scalable, maintainable, and future-ready software that can grow smoothly as requirements change. Now let's talk honestly. Even though the open-closed principle is powerful, it also has some disadvantages and limitations that every developer should know. First, it can increase code complexity. To follow OCP, we often use abstractions, interfaces, and multiple classes. This can make the design heavier and more complex than necessary, especially for small projects or simple requirements. Second, it may lead to too many classes in files. Every new feature is added as a new class instead of modifying an existing one. Over time, this can create a large number of classes, making the project harder to navigate if not structured properly. Third, OCP requires good design thinking and experience. Beginners may overuse it or apply it in the wrong places. If implemented without proper understanding, it can actually make the system confusing instead of improving it. Fourth, it can sometimes result in indirect changes instead of real simplicity. Even though we don't modify old code, we may need to update factory logic, configurations, or dependency injections, which still requires careful handling. Finally, it may be overkill for small or rarely changing features. If a feature is not expected to change frequently, designing it with heavy abstractions might just waste time and effort. So while the open-closed principle is extremely useful, it should be applied wisely and only where necessary, with proper planning and understanding. Now let's understand how the open-closed principle works in microservice architecture and why it is extremely powerful in modern cloud-based systems. In microservices, every feature is developed as an independent service, like payment service, order service, notification service, user service, and so on. Here, the open-closed principle fits perfectly because each microservice should be open for extension and closed for modification. Instead of changing an existing service again and again, we extend the system by adding new services or new versions of services. For example, if your application currently has a credit card payment service and tomorrow you want to add UPI or PayPal, you don't modify the existing service heavily. You simply create a new microservice or a new implementation and plug it into the architecture. The existing working service remains safe, stable, and untouched. This is OCP in action. Similarly, in notification microservices, you might start with email notifications. Later, when you need SMS, push notifications, or WhatsApp alerts, you simply add new services without breaking the old one. Microservices naturally support OCP because they are loosely coupled, independently deployable, and designed to grow by extension rather than modification. This approach gives us better scalability, zero or minimal risk to existing features, faster development, ability to add new capabilities without breaking production. However, we must also be careful. Too many microservices without proper design can increase complexity. So, OCP should be applied wisely with proper architecture planning, API design, and version control. In simple words, microservices plus open-closed principle equals highly flexible, scalable, and future-proof software systems. So that brings us to the end of this powerful session on the open-closed principle. We learned what OCP is, why it is important, where it is used, how to apply it, real-world examples, advantages, disadvantages, and even how it fits perfectly in microservice architecture. If you truly understand this principle and start applying it in your projects, your code will become cleaner, safer, more scalable, and truly professional. Remember, great developers don't just write code, they design systems that handle change confidently. If you found this video helpful, make sure to like the video, subscribe to the channel, and share it with your developer friends. Drop your thoughts, doubts, or topics you want next in the comments. I'd love to help you learn more. Thank you so much for watching. This is Microservices channel, helping you become a smarter and stronger developer. See you in the next video. Until then, keep learning and keep coding. Rocket.